Okay, this is the final exam review. My plan is just to go through and solve all these problems, and then if you have any questions, we'll try to answer them in the next class. So this will be the answer key. Excuse me. So the first question asks us, if an arc of length 10 is cut off from a circle by an angle of pi over 12, what is the radius of the circle? So we're going to use the following formula. We're going to say arc length divided by the circumference, and the circumference is 2 pi r, is equal to the angle, or just theta if you want, over over 2 pi, because that is the total amount of radians in a circle. So for this particular question, we will plug in 10 for the arc length. And I've got 2 pi r. We don't know what the radius is. That's what we're asked to find. And then my angle is pi over 12 divided by 2 pi. The first thing I'm going to do is multiply both sides by 2 pi r to get rid of that in the denominator. Some of y'all may be using the formula that has already done that, which is totally fine. Just make sure that your angle is in radians. With my formula, you could use an angle in degrees. You would just have to put 360 down here. But for this one, it's radians, so we put 2 pi. So just make sure your angle is in radians if you use the formula that doesn't have these denominators. So let's see, I have canceled the wrong thing. That one doesn't get canceled, that one does. Okay, so once we do that, we end up with 10 equals, oh, some parts of that cancel. Let's see, the 2 pi and the 2 pi. There we go. So it'll be pi over 12 r. The last thing we have to do is divide both sides by pi over 12, which is the same as multiplying by 12 over pi. And that will cancel on this side. And we're going to end up with r equals 12 times 10, that's 120, divided by pi. And because it's not a word problem, because we're not told how to round, I would leave this exact. For the next one, we are given the rotational velocity, aka the number of times it rotates around a circle. So it rotates 8 times per second. We want to translate that into angular velocity. And angular velocity is always measured in radians per second. So actually, I wrote out the word per, but I really could have written it like this. Per is just division. So 8 rotations is going to be 8 times 2 pi radians, because each rotation is 2 pi. And that actually should be the angular velocity. That'll be 16 pi radians per second. So that one's hopefully pretty straightforward. The only thing you need to remember is that omega, angular velocity, is equal to radians per second. Okay, if the angular velocity of a particle, so that's the radians per second, which it gives us, radians per second, is 5. So omega equals 5. Find the linear velocity. The linear velocity we call v. V is equal to omega times the radius. So in this case, it's equal to 5, which is omega, times the radius, which is 2. That will give us 10 inches per second. And that is the linear velocity. Number 4, find the remaining sides with 30, 60, 90 triangle. So let me label that. 30, 60, and 90. The longest of the three sides is 3. So hopefully you remember, you do need to have this memorized, that in a 30, 60, 90 triangle, the ratios are A, 2A is the hypotenuse, and root 3A is the long leg. So in this case, 3 is equal to 2A, which means if we divide both sides by 2, we get A is 3 over 2. So the second side is 3 over 2. And then the third side, the long leg, is going to be root 3 times 3 over 2, which is just 3 root 3 over 2. It's not going to simplify, so that'll be the answer. Okay, number 5 says simplify this expression as much as possible after substituting 2 sine theta for x. So instead of x, we're going to put 2 sine theta, and we're going to not divide, we're going to take the root. So the first thing I'm going to do is, because these are multiplied, I can distribute this square. So I'm going to have the square root of 4 minus 4 sine squared theta. Then I notice that they both have a 4 in it, which means 4 is a factor. So I'm going to take out 4 because it's a perfect square. I'm left with 1 minus sine squared theta. Of course, that's equal to 2 root 1 minus sine squared theta. Then you may remember that 1 minus sine squared is equal to cosine squared. And once we do this, we can say that this is equal to 2 times the cosine of theta. And that'll be our answer. Although, as we learned in the most recent section, it's probably wise to stick an absolute value because we've got a square and a square root, which will end up giving us the positive only version of that. So the full and complete answer should be this. Okay, number 6. It gives us a triangle, ABC, and it says that C is the 90-degree angle. And then it tells us that side A is 2 and side B is 1. And it asks us to find the 6 trig functions of A. So the first thing I'm going to do is A squared plus B squared. So A squared plus B squared equals C squared, which means that 4 plus 1, that's 5, is C squared. So C is the root of 5. And that is what I will label the hypotenuse. Then I just need to do sine. Sine is opposite over hypotenuse. Rationalize the denominator, I get 2 root 5 over 5. Then I'll do cosine. Cosine is adjacent over hypotenuse. Rationalize the denominator, I get 1, which doesn't need to be written. It's just root 5 over 5. The tangent of A is the opposite over the adjacent, which is 2 over 1, or just 2. And then from here, I can say the cosecant of A is sine flipped over, so it'll be root 5 over 2. The secant of A is cosine flipped over, so it'll just be root 5. And then the cotangent of A is tangent flipped over, that'll be 1/2. And these are our final answers. Okay, number 7 says find the exact value of the expression 4 sine of 60 degrees. So I like to draw my unit circle whenever I encounter something like this. So 60 degrees is right here. That is a 30, 60, 90 triangle. Y is the long side, it's root 3 over 2. X is the short side, which is a half. The hypotenuse is always 1. So the sine of 60 degrees, which is right here, sine is opposite over hypotenuse. It's root 3 over 2, which means that 4 sine 60 degrees is 4 root 3 over 2, which simplifies to be 2 root 3. Okay, number 8. Find the exact value of the secant of pi over 2 minus x if x is equal to 2 pi over 3. So you may remember that the secant of pi over 2 minus angle is the same as the cosecant of the angle. And the cosecant is 1 over the sine of the angle. So we are looking for 1 over the sine 2 pi over 3. So what I'm going to do is draw it in my unit circle again. So 2 pi over 3 is in quadrant 2, right about here. 2 pi over 3. This distance is pi over 3, aka 60 degrees, which means that y distance is I can make it a little better. Here we go. Probably more like this. The y distance is √3/2. So the sine, the opposite, is √3/2. So the answer is 1/√3/2, which is 2/√3. If I rationalize the denominator, I get 2√3/3. Okay, number 9. It gives us two sides. So it says use a calculator to find sine A, sine B, and cosine B. So let's see. Sine A is going to be, well, let me draw a picture. It's opposite over hypotenuse, but the best way to do that is probably draw a picture. So yes, here A is unknown. We'll find that in a minute. B is 8.82 and C is 9.67. So that means A should be the square root of 9.67 squared minus 8.82 squared. I'm going to give myself just a little more space on that one. That is what I can put into my calculator. So that means the sine of A is going to be opposite, which is root 9.67 squared minus 8.82 squared divided by the hypotenuse, which is 9.67. And that I'm going to put in a calculator. So let's see. In a calculator, it will be root of 9.67 squared minus 8.82 squared. And then I'm going to divide that whole thing by 9.67. And I get 0.4410. Oh, but it tells us to just do two decimal places, so 0.41 is the right answer. Then for the cosine of A is adjacent over hypotenuse. That's 8.82 over 9.67, which again I can do in the calculator. 8.82 over 9.67, and that will give me 0.91. From here, I don't need to do any more math because I know that the sine of B is equal to cosine of A because they're in the same triangle. So it will be approximately 0.91. Similarly, the cosine of B is the sine of A, which is about 0.41. And these are our four answers. Okay, next, number 10 says use a calculator to find the following. Round your answer to 4 places past the decimal point. So the first thing I notice is that this says secant, which is not easily accessible in our calculators. So I'm going to change it to 1 over the cosine of 46.7. And 1 over the cosine is something that I can put into my calculator. So I will just do fraction 1 over the cosine. Oh, what was it? 46.7. 46.7. And I should double check because that does not look right to me. Well, maybe it is. I should double check though. Am I in the right mode? I am. I am in degrees, so we are good. 1 over the cosine is 1.458. And it tells us to round to 4 decimal places, so that's 1.4581. 1.4581. And again, on this type of problem, whenever you're taking the sine or cosine or tangent or anything else, and you're typing in an angle, make sure your calculator is in the right degree, the mode, degrees or radians. So number 11 says this problem refers to the right triangle, ABC, with C is 90 degrees. So again, it's probably a good idea to draw it. Okay, solve for the missing parts using the given information. It says angle A is 21 degrees and C is 27. They want us to find all the missing parts, so I'm going to start with side B. To find side B, I notice that the sine of 21 degrees is the opposite over the hypotenuse. So it's B over 27, which means that B is equal to, if I multiply both sides by 27, I get 27 sine 21 degrees. And that I can find in a calculator. 27 sine 21. 27 sine 21. And I'm still in degrees. So that's 9.67 or roughly 10. Then I'm going to solve for side A. For side A, I'm going to use the cosine because cosine is adjacent over hypotenuse. The adjacent is A and the hypotenuse is 27, which means if I multiply both sides by 27, I get that A is the 27 times the cosine of 21 degrees. And that will give me 27 cosine 21 degrees, 25.2, which is roughly just 25. It does say to solve for all the missing parts, which means I need to find the missing angles. So for angle B, there's a lot of things I can use. I'm probably going to go with something like sine again. So sine of B is the, did I do that wrong? Hang on. This is A and this is B. I think I have these backwards. I do have these backwards. This is A, this is B. That should fix it. Yeah. I should have labeled my triangle. That's why I made that mistake. Anyway, sine of B is opposite over hypotenuse. So it's B over 27. Well, I've already found B. It's roughly 25 over 27, which means that B will be the inverse sine of 25 over 27. And we know that B is an acute angle because in right triangles, all the angles except C are definitely acute, which means it is in quadrant 1, which means whatever we get when we type this in the calculator will be the final answer. There's no reason to check for another one. We only have to check for another one if it's not a right triangle. So I'm going to do the inverse sine of 21 over 27. Inverse sine 21 over 27. And that gives me 51 degrees. 51 degrees. Finally, I know that angle C is 90. You know what? That's fine, but I just realized here's a better way of doing it. Find angle B. I should just do 180 minus 90 minus 21, and that's going to be a lot more accurate. Mine had a rounding error. It's 180 minus 90 minus 21, 69 degrees. I was way off. I don't know what I was doing. I think it might have all been a rounding error, but this is much better. That's it. Those are all the missing sides. Okay. Number 12 says find the exact value of the cosecant of negative 225. Again, cosecant is not one that's in our calculator. It's not one that's easily accessible in the unit circle. So the first thing I'm going to do is write it as 1 over the sine of 225. Negative 225. The next thing I'm going to do is I want to make it positive. So I'm going to do negative 225 plus 360 because adding 360 doesn't change anything. When I do that, I get 135. So this is the same as 1 over the sine of 135. And that is on my unit circle. I'm going to draw a picture. 135 is 45 degrees away from 180. It's like right here. And that is a 45, 45, 90 triangle, which means the sine is root 2 over 2. So this is 1 over root 2 over 2, which is 2 over root 2. If you rationalize the denominator, you get just root 2. I can always double check it by doing this. I can say 1 over the sine of negative 225 is this. And let's see, the root of 2 is the same thing, which means I have done it correctly. Okay, number 13 says draw the angle in standard position, find its reference angle, and convert it to degrees. So standard position means on the unit circle. 7 pi over 3, well, let's see. That is bigger than 2 pi. So for that, we'd have to go all the way around, that's 6 pi over 3 plus another pi over 3. I end up right here. That's at 60 degrees. So here it is drawn in standard position. Its reference angle is this guy right here, which is pi over 3. Finally, to convert 7 pi over 3 to degrees, I need to multiply it by 180 over pi. And here, my pi's will cancel, which means I get 7 times 180 over 3. And that I can do in a calculator. So I'm going to do 7 times 180 over 3, and that's equal to 420. Okay, number 14. Draw the angle 135 in standard position. Find a point on the terminal side. Find the sine, cosine, and tangent of this angle. Well, 135 is right here because I know that it is 45 degrees less than 180. So the point on the terminal side is this guy right here. The x coordinate is negative root 2 over 2, and the y coordinate is root 2 over 2. So the sine of 135 is equal to root 2 over 2. The cosine of 135 is negative root 2 over 2. And the tangent of 135 is negative 1 because it's sine divided by cosine. Okay, number 15 says find the remaining trigonometric functions of theta based on the given information. We're given cosine, so what I want to do is I want to draw a picture of my triangle. And this is the right orientation because I know my triangle. Well, yeah, I'm actually going to draw it in the unit circle. That was correct, but I'm going to add it to the unit circle because I know it's in quadrant 3. 2, it's in quadrant 2. It says quadrant 2, and that is a picture of quadrant 2. So the x is negative 35, and the hypotenuse is 37. So to find the missing side, I just do square root of 37 squared minus 35 squared. That I can do in a calculator. Square root of 37 squared minus 35 squared. That will give me 12. So the opposite side is 12, which means that the sine of theta is 12 over 37. And then I can do tangent of theta. Tangent is opposite over adjacent, so that's negative 12 over 35. Then I can do the secant, which is cosine flipped over. It's negative 37 over 35. I can do the cosecant, which is sine flipped over. That's 37 over 12. And then I can do the cotangent, which is tangent flipped over. It's negative 35 over 12. And that should do it. Okay, number 16. Find the cosine if sine is equal to root 3 over 2 and theta is in quadrant 2. Same exact idea. Quadrant 2, right here. And if my sine is root 3 over 2, I know that that means my adjacent is negative 1/2 because it's a 30, 60, 90 triangle. So the cosine of theta is negative 1/2. Okay, number 17. Find cosine, tangent, secant, cosecant, cotangent, and then it gives us sine. It says it is not in quadrant 3. Well, the sine is negative, which means the only place it could be is in quadrant 4 because it specified it was not in quadrant 3. So if this is our sine, our cosine is going to be root 3 over her 2, and our hypotenuse is 1. So the cosine of theta is root 3 over 2. The tangent of theta is sine over cosine. It's negative 1/2 over root 3 over 2. Those 2's will end up canceling, and we get negative 1 over root 3, which is negative root 3 over 3. The secant is cosine flipped over, so that will be 2 over root 3, which is 2 root 3 over 3. The cosecant is sine flipped over. That's -2. And finally, the cotangent is tangent flipped over. It'll be -√3. Okay, next, number 18. We're going to use a calculator to find a value of theta between 0 and 90 that satisfies the statement. Okay, so we know that the cotangent of theta is 5.2715. Again, cotangent, inverse cotangent, not easily accessible in my calculator, so I'm going to write this as tangent. If the cotangent is 5.2715, the tangent is 1 over that number, because tangent is always 1 over cotangent. Then, because it says I want to be between 0 and 90, that's the first quadrant. When I take the inverse tangent, it's definitely going to give me something in the first quadrant because tangent is positive. And quadrant 1 is our favorite, so it will definitely give me something in quadrant 1. So I just have to put this in my calculator. Inverse tangent of 1 over 5.2715. So inverse tangent of 1 over 5.2715. That gives me 10.7413, aka 10.7 degrees. Okay, number 19 gives us another triangle. Instructions are first to draw a picture. So we've got A, B, C. A is 41.7, B is 30.8, and they want us to find angle B. This time we're going to do what I was trying to do in some previous problem. But if we want to find B, we need an equation that relates these two sides. And a good equation for that is going to be tangent. The tangent of B is the opposite over the adjacent, which means that B, it is going to be equal to the inverse tangent. We don't have to think of other possible values because I know B is acute. And since it's acute, it's definitely in quadrant 1. So I can just put in my calculator, inverse tangent 30.8 over 41.7. So inverse tangent 30.8 over 41.7. That will give me 36.44 degrees. Doesn't tell me what to round to, so I'm just going to put 36 degrees. Okay, number 20 says find all the angles theta on the unit circle for which sine is √2 over 2. So I know that √2 over 2 is a 45, 45, 90 triangle. And I also know that sine is positive, which means it's got to be in quadrant 1 or quadrant 2. And there's nowhere else. So this first angle is 45 degrees. And the second one is 180 minus 45 degrees, or 135. And those are the only two answers, 135 or 45 degrees.